And last in this overview category, we'll have Jaime Jiménez, working for Ericsson, who also have the pleasure of working with in the context of the ITF. You can start the screen share, I think. And now that we've covered the energy that we need to run the things and the security, the S in IoT, that we need to connect them to the internet, let's go to the most important part, that is actually using it. And Jaime has worked on making the IoT more usable with the help of AI agents. Yes. Take it away.
All right. So without further ado, so I'll talk today. So Hannes mentioned AI, and on the side, on top of in addition to the IoT stuff that I usually do, I have been tinkering with AI agents before they were cool. This year, somehow the whole thing has exploded. Everybody's talking about it, but actually a couple of years ago, we were already working on it a little bit. I mean, none of this work could be possible without Tom and Lorenzo, who are not here to present. I'm presenting on behalf of the whole team. And basically, the work started as some sort of a pipe dream of mine. If you have been in the ITF long enough, you probably remember the concept of HATEOAS, hypermedia as driver of the application state, and you know maybe Coral, maybe you know HAL, and other descriptions and semantic descriptions. And the point of HATEOAS is not very popular on the web, by the way, on the API world. It's not very common. Normally, when you develop applications for APIs, you read the API specification, you basically the YAML file, you implement your client, and you keep the development cycle. So this domain is unsighted. I don't want to get into argument, but like basically it kind of summarizes a little bit the problem at the time, because conceptually a hypermedia client is something very complicated to implement, but even to understand, because it's essentially a client that would work with any random API, because you would get all the information on how to interact with the API in-band. So you wouldn't need a YAML specification. You wouldn't need to be an implementation specific for that particular API endpoint, but rather it would work with other API endpoints. Over HTTP, you do have some of the abstractions. For instance, now in HTTP APIs, they have this API catalog. They have mechanisms to get notifications in-band, like servers and events. You can set up webhooks, but it's not easy to implement. At least back in the day, a couple of years ago, we were implementing this type of a smart client. And what we had to do was essentially, via LLMs, by the way, we had to provision the LLM-based application with the YAML specification, and it was capable of crafting most of the time correct HTTP requests and parse the HTTP responses. But of course, being a non-deterministic system, it was not very reliable at the time. And what I wanted to do is to do it over CoAP. But I didn't get time until this year, which we finally did something based on that. So I took these slides from Matthias, who gave them to me. And it kind of gives you an overview of what a hypermedia HATEOAS-like client would do with the right abstractions. This is for thin descriptions, but it would work with other semantic description. So you will have a client, CoAP client, and as you know, you will have a resource directory. You will do discovery on it. You will discover links, and you will follow those links. You will find a thing that will be self-described, that maybe points to another resource, and so on. And you can submit a form and interact with it. You can find other things, and maybe as the application is being executed, you can also add new functionality. For instance, you could have a thing and then add some sort of authentication mechanism. So dynamically extending the process flow. So what I really wanted to do is to do this, and I believed, and basically that's what we have done. It was possible with LLMs, basically. And it's HATEOAS-like. It's not fully HATEOAS, because at the end of the day, it's an LLM-based, but it's a pretty close abstraction to it. So how does the system look like? This could be a general purpose agentic system. Basically, usually you have some sort of user that has an intent in natural language, describes it, and then it goes into the agent, which has what is called a react loop. It could be, so reasoning and acting loop is a technique by which you ask the agent to self-reflect on the planning steps to solve a task. And then the executor will execute each of the steps. We added some other additional features, like bookmarking, so that it knows the links it has traversed, execution history, so it kind of remembers what it has been executed in the past and maybe reuses it if there is a lot of, if both the user intent and the state of the devices match. And then the user preferences. As you use it, basically the system can learn what the user wants. And then this system, you plug them to external knowledge sources, like in our case, we were just doing web search. And also the LLM that you use is pluggable. So the LLM for the planning logic and for the reasoning steps is something you can plug and play. And we tried a few of them. And then the particularity of the system is that we focus on the IoT devices. And we wanted to have it like with raw IoT CoAP-based calls, no middleware, no MCP, no nothing in between. So very briefly here, so what is the knowledge base? It's whatever the LLM has been trained with. And that's the LLM part. What is the search function of the knowledge base? So it's just simple web search. So it has a headless browser and it can browse for some information if it doesn't know it from the training data. The LLMs, we have trained GPT-4o, DeepSeek, and the Llama 3.3 locally. You can run it also with a Llama, for example. You could run it on the computer, but it takes a bit much longer, actually, to execute. Then the agent itself, as I mentioned, is model agnostic. We haven't tried multimodality, so it's only for text-based operations. Another particularity of this agent, of this small agent implementation, is that it's a code agent. So as you will see in the demo, each of the reasoning steps gets translated into little Python snippets that make function calls to the tools that it has at its disposal. When I show the demo, it will be much more clear, by the way. I'm pretty sure. But just remember, I said that. And then on the memory tools, basically, we try to keep track of the devices that have been found, store the execution history to reuse the Python code. So this agents are non-deterministic by nature, but if you had similar executions, you just reuse the Python code and then you get some sort of deterministic behavior. And then the user preferences, as I was mentioning as well. Then on the CoAP side, we were using IO CoAP from Christian's. Or is Christian? From Christian. Very easy to use, so of course we chose it. Each device is a little CoAP server, you know all of this. And maybe the interesting part is this abstraction. So MCP and in general, all the tooling tends to be more RPC-like. So all the functions are incredibly specific, and that could confuse the agents because essentially you have 20, 30 different potential tools that are maybe called similarly. We decided to get the approach, to make the approach that is more towards REST. So we try to map it to fundamental REST operations to avoid confusion. And it turns out that this simplicity actually does help on the execution of the agent. So basically we can discover things with well-known core that is mapped to the least resource function. We get the current value. So it's a get to a CoAP URI. Set value, put post to a URI, and then subscribe pattern, we do it with observe. And the subscribe pattern is important also to know that something has actually happened in the real world and the desired execution has actually occurred. So I'll get to the demo. All right, so we have on the right side of the screen, I just use, it's so complicated with this. So on the right side of the screen, we have a bunch of CoAP devices, temperature, humidity, the usual simple setup. So you can do a get and get the current temperature, get the status. You can do the observe. I mean, I'm not going to explain you how it works. You already know. So let's say on the left side of the screen, I could say something high level to the agent. Like if it's a bit cold in here, and then it will start executing. So what happens first is that, and let me see that, it's running. So you will start finding the devices that are around in the HATEOAS fashion I was mentioning, find the ones that are related to the temperature as the user intended, and then try to change things. And let's go step by step. So this is basically a common pattern, I hope. So first is the planner. No, well, first is the paraphrase mini LLM here, this part. So what we are doing here is taking the intent and try to homogenize it so that future intents that are saying similar things will be detected as being similar. Then the agent, what it does is start getting some facts. So it gets essentially this is the React loop. So it does first the planner takes the input from the user. Then it has some functions that it can use. So we have given it the possibility to use get resource, the possibility to do set resource and list resource and so on. So it does a plan, and the plan has these 9 steps. In this case, other times it's a bit different, and it starts executing on them. So the execution, as I mentioned, is being a code agent. Each of these steps is a little Python snippet. So it executes the first one, which is get the well-known core in the Dockerized environment and gets the devices that are there. Then from the devices, it finds the temperature, follows on step 2. So it finds a temperature resource, temperature endpoint, and does a get on it, retrieves it, prints it out, and then based on that, it starts going to the next step and starts analyzing. So in this case, for instance, it does a web search for the ideal room temperature for comfort. Other times it just goes with the execution. In this case, it just finds on the internet that there is some degree of comfortable temperature for it, for most users, and gets the current value of the thermostat, which is 20, and then it tries to modify it. And then it sets, which is kind of nice, sets an observation on the temperature resource to see not only that it's modifying the thermostat, but that it actually, the temperature reaches that value. Right, so, and then it tells the user that the room temperature has been adjusted to 22, and then we can see that it is indeed 22. Now, if I add something like that again, it should detect that it's a similar command, and I should have actually set it up to 20 first. Anyway, so it will execute again because the system state is not the same as before. Let me just wait for a moment. It does another execution, and it says that actually 22 is within the comfort range, and it doesn't need to change anything. But it's kind of like letting me know that it's fine, that I'm wrong. And let's wait this for the thermostat, for the temperature to reach. Let's see what happens. So it should detect at some point that the paraphrase LLM should detect that the actual input is similar. For some reason, it's not detecting it this time. So it's just doing it again and trying to figure out the user intent. Anyways, so that's another one. Other things we can try, for instance, you can be more, the user can be more vague in the intent. So as an example, right. So for instance, if the light is off, so we could say something like, if the light is off, don't do, change something or don't change something. And then it should actually detect that the light is off and it will not do it. And then we can try again with the opposite. It's a second. It's now observing the thermostat to see that it has finished the operation. Takes a bit. We have also simulated the time it takes for the temperature to change, which makes the demo a bit longer. Oh, right. Okay, so I'm running out of time. Okay, but just a second. So since we have only 5 minutes more, let's do it like this. After this presentation, we can start tinkering a lot if you want, and we can start playing with it. Let me just stop the sharing and go back to the PowerPoint. All right. So the demo, I show part of the demo, but what happens is that The agent needs very little a priori knowledge to operate. So it only needs the entry point, and it can do discovery, and it can use the raw CoAP operations. You can pass it. You can tweak the planning interval to see how often you want to go back to the planning stage. You can also tweak the maximum steps that you want to give it so that it kind of tries for a bit longer to fulfill the user intent. In principle, it's not IoT specific, so the resources exposed could be about network information. It could be about anything else. I didn't show it in the demo because it didn't crash this time, but basically, when you pass the user intent, I mean, it doesn't really crash, to be precise. Actually, it does the operations, but for instance, let's say that it generates executable Python code that doesn't work. Then the Python interpreter will throw an error, and it will go back to the planner, and it will try to execute with a different version again. Like it will try to modify the code a little bit to make sure that it's working, which is pretty cool, actually. It makes it pretty robust, even though it still is non-deterministic. So it has pros and cons, I guess. Then, as I mentioned already, it can discover capabilities, the link attributes, resource types, media types. The richer the descriptions of the devices, the more accurate the agent is. It can also incorporate in real time the state that is using from the system. So if the system state is for some reason different and the user intent doesn't match, you will just proceed through a different path. It's not like a repeating the same behavior unless the system is exactly the same. But it can basically adapt to different system conditions. For instance, in one of the occasions, one of the devices was not reachable because it fell, it crashed. So it was telling me, the user, like, oh, I cannot find anything that can help you with this, for example. And then also it's kind of cool that it observes the state until task is completed, which is something that is pretty unique of CoAP, I would say. At least it's easier with CoAP. So in conclusion, basically this agent works as a HATEOAS-like client. Yeah, it has a minimal tool set to operate. There is no need for, I mean, you can build an MCP server that has a CoAP on the other side, and then the MCP client on the other, but it's unnecessary because you can just do it with raw CoAP. It uses interaction affordances to adjust the execution steps dynamically. It is fundamentally different than usual software. So this is not normal software that you implement a client application, you do software updates. This is a different thing. And it can be made, it's non-deterministic, but it can be made deterministic by simply using the previous code executions, for example. I mean, it's all very early stages because this whole domain seems to be very early stages. But I foresee, for instance, in areas like network management or device management or user-oriented operations that can tolerate a bit of a higher latency, and they can be 90-something% reliable, but they don't require the 99.9999 reliability. I could see many applications of this. Yeah, and I think I'm already pretty much over time. I don't know, like we spend a bit of time with the window switching. Sorry for that.
Yeah, you don't have to rush to the last slide. So
okay,
finish that part.
All right. So yeah, so basically, I could see this. I mean, there is clearly momentum in the industry for this. We are at the top of the hype curve. For sure, in a few years, we will see things, end in a way in the agentic domain. But I think there is a lot of useful use cases and useful technology here. And yeah, I'm not so sure of the role of the standardization. For example, I see different de facto standards that are there. I see different building blocks being built, for instance, in ITF or in other venues, but it's very early stages and it's pretty interesting. I think maybe after this, I can show to others a bit of a longer demo and we can give more testing on my laptop. Yeah, thank you.
Thank you.
Yeah.
Yeah, thanks. I'm wondering, it seems to me like what would sense in this space, because it seems to me like this, the LLMs line and basically make sure that there are no stupid side effects, right? So if I'm code, because it's on the offer.
I cannot hear you too well actually with the mic. Like, what do you mean? Like, where do we put the LLM? Sorry.
And now where do we get sense so that the system doesn't receive?
So yeah, I mean, evaluation is required. We haven't done an extensive evaluation on a real life system. I can tell you that in general, it doesn't try to do strange stuff. But of course, you know, LLMs can be overfitted. So it could be that it works well for a long time and then all of a sudden you get an attack of some kind. So you must have some sort of a trusted LLM provider, or you need to put some firewalls. You could also validate the input and output from the LLM towards the IoT devices, for example, like just to make sure that they don't go over thresholds, things like that. But it's an intrinsically different technology than normal code is. So it's not just a variation; it's completely different. So it's hallucinations, as far as I know, are very much entrenched. And it could hallucinate. More.
Sorry about this. This is super interesting. But I'm wondering, in practice, it seems like it's a multi-agent for a system. In the sense that if I'm, for example, managing at home, I may have a system running all the time where I try to keep my energy bills down. Mm-hmm. And then I have it on, and so that's going to generate and create a sequence of things that operate over a period of time. Mm-hmm. And then at the same time, I say, as your example, I'm still cold. And perhaps my insurance company or somebody else is putting another agent into my home is monitoring for a break-in or something. Right. It seems like, if you thought about personal way to describe some interaction between agents with like different.
So the hype is very high and the people want to put agents everywhere. So if you have very efficient code that does something, I wouldn't put an agent there. Like if you have a simple monitoring system, then that's it. But for instance, if you have something that is more user oriented, for example, and you require this kind of flexibility and ambiguity that the user has, and usually that is expressed via the natural language, because the user is just telling the IoT system what to do. I think in those cases it's very useful. When it comes to multi-agency, what I have seen is more like specialized LLMs that have a very particular context that other general purpose LLMs do not have. Like they have been trained on specific data and they tend to operate really well for that type of content. So you may have, I mean, what people are trying to build, for instance, with agent-to-agent is you have a coordinating agent, and then you have multiple smaller agents that are specialized in the domains, and then they are exposing some interface so that the other agent can talk to them. And then the other aspect of multi-agency is if you have video or audio or images as well. I have only experimented in this demo with text, for example. Yeah. Right. Alice.
Did you try to include authorization interactions as well?
Not yet, but there is, as you know, in OAuth, there is interesting work on Stephen, for example, like so the API world is a bit different than the IoT world. And what I see in the API world, until very recently, for instance, MCP was using the same JSON web token you use for your application, you give it to the agent, which is dangerous, obviously, because the agent can do many things. So what I see is that there are different, what is happening is some sort of tokens that are, new kinds of tokens that are scoping down the access that the agent has. Another way to do it is also to the different access to tooling. For instance, if you don't want the agent to break anything, you can just put the discovery, and in this case, some of the tools discovery get subscribed are allowed because they don't change anything. And for the setter, you need user verification, for example, that's another pattern. But yeah, that is also in progress as we speak. Like I think MCP, for instance, recently adopted some ITF drafts on it, one from OAuth, one from HTTP API, for example, on the API catalog. And it's evolving very rapidly, actually. It's kind of hard to be up to date because changes happen every week. It's something new. Yeah, I have given you some thought for this, but I haven't implemented it. Sorry.
Actually, that's also.
Any further questions? Seeing none, thanks again, Kevin.
Thank you.